Okay, so let me share my screen. Give me one moment. Let me just put the screen up. Share, start slideshow. Screen. What we're going to be talking about now is very important. Is many the best. I mean, what we're talking about now is what we're aiming at. In fact, statistics is something that we use to do to make decisions. Let me just stop sharing for a minute. I need to add a slide. One moment. Statistics is what we use to make inference about stuff, to make decision. That's why I said last time. Okay. So whenever you use statistics, it's going to help you make the best decision ever. So based on your own research, then you can make a decision. Okay. Let me see, new slide. Okay, let me just share my screen now. Save that from the beginning. Oopsie, no. Give me one moment. I think I'm putting too much slides here, so I don't need that extra slide. Okay, so let me share the screen. Slideshow from the beginning. Minimize that and share my screen. Yeah, so this is why the idea of hypothesis testing will come in place. So this is people is going to make claim. For example, you might want to say, maybe I should go to this hotel for vacation. Then what I'm going to be doing, you're going to make research with something in mind. Okay, you probably want to go to a specific hotel place, and then you say this hotel is 5-star, this one is 2 stars. Then you start studying the hotels around the area that you want to go to. Then first of all, you had a claim in mind. So is this hotel good? So based on the research that you're gonna be doing, it's gonna make the decision. Okay. Sometimes even though it's a 4 stars, you might say, oh, I know people there in this hotel, they served me before, I'm gonna take it. Sometimes not all the time, the 5-star will be the one that you want to take. Or maybe it's a 3 stars, and then the person who owned the hotel is your uncle. So I say, I want to go there. But you make the decision based on your own research. Okay. What I'm talking about here, let me see, I think I'm sharing. So what happened, somebody gonna come with something called a claim. You're gonna have a claim in your head. The goal is whether to reject that claim, okay, and not reject it. That'll be the goal. Not rejecting. Reject or do not reject. You see, that thing again. You can say reject or do not reject. Okay, that's the goal of the claim. Do not reject. Okay, somebody can come with a claim saying that Walmart is so expensive. That's the claim of the person. The person said Walmart is so expensive. Okay, that candy, something like that, is more than $3, something like that. Okay. So you're gonna say, oh man, Walmart is so expensive. Look at that Candy's price. It's $3. It's more than $3, something like that. Then that's a claim. And then if you're somebody that is very important, so about the handwriting here, I just lost with the cursor here. So suppose you are a person that is very important, a well-known person in the country, and then you go out and make that kind of statement and say Walmart is so expensive. This candy, okay, I forgot to put candy. I want to put candy right here. I'm sorry. That candy is so expensive. It's more than $3. If you're somebody that is so important, very well known and very well known in the country, if you do a statement, what happens is that Walmart sale can go down just because of your statement. And that's why we see also Elon Musk, whenever he do a statement about a company, if he just does it like this, then the second go up or the second go down. And then we said you saw people on the news, whenever they make statements, some companies lose money. And also the market can crash. So your statement can affect the life of a business. It's very important that you pay attention to that, what you're saying. So here we have a statement saying that a claim is, I can say this is, I suppose this is, I'm using the mu statement. On average, this candy is more than $3. Okay, that's what I'm saying. Okay, so this is very important. That's what it's asking. If we are go on Walmart, I'm expecting that candy to be more than $3. From this statement only, we can, because you say you're gonna have to reject or do not reject. We can create two things, something called a null hypothesis. Oopsie, again. Bear with me with that thing from that cliche from PowerPoint. A null hypothesis and the alternative hypothesis. Okay, so now I'm missing off right here. So hypothesis, I find it, okay? So whenever I got to these two things, the symbol that we use for the null hypothesis is something called H naught. I'm gonna talk about it later on. And the other one, you're gonna say HA or H alternative, HA. Some books like to put H1. Okay, or that you say H0 and H1, or say H0 and HA. Either way is fine. Okay. Now, because this is your claim right here, what's gonna happen? H0 here only use equalities. Equality symbols only apply to H0. Equality symbol shows as less than or equal than, greater or equal than, and an equal sign. And then for the alternative hypothesis, you only perceive inequality. Okay, such as less than, greater than, and not equal to. Okay, in our case, your claim is, this is your claim right here, that the candies are more than $3. So if I build on my hypothesis, I'm going to say something like this. I will say H0 and HA. In this case, HA and H, I'm going to put this one. Mu is greater than 3. And if for H0, I will have to say mu, sorry about it. I can say mu is less than equal than mu is less than equal than 3. I do the opposite. So they can be a complement. Another way to write the same thing is also that way. I can say H naught and HA I will say mu and then mu I here. This one I will say greater than 3. And I can just say equal than 3. The reason I have it equal than 3 because this symbols means greater or equal to. Okay, or equal. All right. And other side, another way is, for example, I have a claim that say, well, I'm getting more on a back and forth here. If I have my claim such as I say, for example, P is equal to 0.25. P is a proportion, okay? So whenever I talk about proportion, put P. We'll talk about that in the previous class. Okay? 0.23, for example. Wow. Let me just, okay, 0.23. I don't know, my computer Bible is coming frozen. 0.23. Okay, so in that case here, I will have H naught and H1. Okay, first I'm going to write the claim. The claim has an equal sign on it. So I'm going to say P is equal to 0.23. And the other guy, which is H naught, or I can say HA or H1, doesn't matter. I can say P is not equal to 0.23. Okay, and so on. I'll be going over some examples that I'll be clarifying more in depth what I'm trying to explain to you. Okay, so let's go first. That was just an introduction. So for the hypothesis test, this was this one. This one say, how do you determine if someone is cheating when they toss a coin, for example? I know the term cheating can be like, it means like deceiving. Okay, that's what it means here. So if a person tosses a coin, is a fair coins, the probability to have heads will be 0.5. And the probability not to have heads 0.5, also not to have head will be not equal to 0.5. Anyway, it's going to be 0.5 anyway. Okay. So if only 15 heads come up out of 40 toes, can we say that person is cheating? It's hard to say because we say that the coin is a fair coin. To have a head is 0.5, and then the other one is going to be 0.5. It's hard to cheat with a coin whenever you twist it. Even though you got 15 heads out of 40 toes, it's still going to be hard anyway. Okay? It's still going to be very hard. Even if you do 15 out of 14, even though that number is less than 50%, it's still hard to determine whether the person, because it's a fair coin. Okay? So that was the question. That was the idea to try to make. The idea was trying to make you understand that whenever somebody make a statement, it can be deceiving. That's the idea behind that. Okay, even though the solution can either look good, something can be deceiving. Like for example, if I make a statement, I'm a very important statement. I'll make a statement about Walmart, then my statement will go and it can mess up in Walmart. Sometimes my statement can be a false statement. Maybe that day that candy was specifically high with a high price. Or maybe I'm trying to make Walmart lose business because probably I have my own on the side, then I'm trying to make false statement. That's the idea behind that, okay? So don't look at the problem the way it is right now. As I told you, the dollar hypothesis, we can say H not H, we can say HOB equal 2.5. Use whether H not or null hypothesis, okay? So that's mean then because it P is equal to 2.5, this one you have the heads, that's mean you have no cheating here. And this one say this is opposite, it can be the alternative hypothesis. Some people like to call it H1 as well. That's the way I'm trying to introduce you to the idea behind that. Okay, this is what we hope or guess is true. So we're guessing that whenever the person throws the point, it's not going to give you 0.5. Okay. So here in this case, knowing that the P is the population proportion, hypothesis testing is always the for population parameters, never the statistics. So what you want to do now is trying to get a better idea about the proportion, the population proportion. Here, one is proportion. Okay, so proportion P for population. So we want to have an idea about the population. Okay. So in that case, you can build up that we're gonna start build up the hypothesis that the hypothesis. Okay, so let me see. Let me say something before I continue, so I don't go over. I need to get over something quickly. All right, then. So this is just introduction to some. So you can say choosing donor and adding hypothesis. This one say first come up with an idea of hypothesis. This one said the dealer is palming aces. Okay. And then this one say babies are born less often on Tuesdays. Okay. This is just examples. I just talked about a couple examples earlier. So for example, this one say the dealer is palming aces. I can just say something like this. I can say HO is equal to 1/4, something like that. Okay. Just like the earlier examples, and then for the other one, maybe more or less often, this is going to be the null hypothesis. But this is very important. This one say less than, because this one say less than, it always goes with what you call the alternative one, because I just told you earlier, alternative only require inequality. So here you're gonna say that guy, because it's a less than. So this is going to be the claim right here. This is your claim. It goes with the another hypothesis. Okay. Now, because this one say is, whenever I say is, it always means equal. In that case, this is the claim right here. So based on your statement, you can either put the claim on either the null hypothesis or the alternative hypothesis. Okay. Any question about that? Any question about that? Any questions?
No.
Okay. So I want to make sure that I don't overwhelm everybody. Okay. So now there's something that is very important that we need to know. There's something called level of significance. Okay. We kind of talked about it a little bit last time, something called alpha. Okay. This is why this is what we're going to compare with what do you call it again, with something called a p-value. We're going to talk about this. So what is the level of significance alpha? Suppose I say I'm 95% confident. 95% confident, my 95% confident. That my results are true. something like that. That means the alpha is how much you need to get to 100%. In this case, you have 95% confidence. That's means alpha will be 5%. And then alpha will be what we call a level of significance. Okay, if I say I am 99% confident that my thing is correct, therefore your alpha become 1%. Okay, or you can say 0.05, you can say 0.01, and so on. That's why I say we kind of talk about it before. Whenever we're doing the critical value, the number that we use to put in front of that margin of error, I mean the standard error. So we say that if you say 95%, you use this type of number. That's what that alpha comes from. The alpha is how much you need to get to 100%. So that means is what you call the alpha. Also, it's called the rejected region. It's also called the rejected region. Rejected region. What you don't want to have. Suppose I say 95% of the time I'm right. It means that 5% of the time I'm gonna be wrong. Remember, in statistics, you don't want to say 100%. If you have your business, so in the future you create some good product, you don't want to say that's gonna be 100% efficacious. You have to give some room for error. So when the error happen, you don't get sued for it. Okay, so you're gonna say 100%. I remember one time Elon Musk was doing a review of his truck, the Cybertruck. I remember that thing, and they said the guy to hit the window. So he was 100% that the window will not be broken. But when it happens, the window broke. The guy was hitting so hard. So the window of the passenger seat, I mean the driver's seat, was broken. Kind of weird, but anyway. But we don't want to say 100%. Okay? So always leave room for error. We probably can say 99.9% is going to be fine. Okay? Prefer saying that so to make sure that you don't get messed up. All right? So that's what happened with the level of significance. This is what we don't want to have. We don't want to have that 5%. Because when that 5% happens, is when our product is not working fine. Okay? So that this is why I say here, this is the idea. So concluding that the quantum is not fair when it is fair, saying that the defendant is guilty, but is not, they did not commit a crime. So it's just the idea I'm trying to explain to you about what I was trying to tell you earlier. We're gonna define something called a p-value. Okay, which I will talk about it later on today. They're gonna compare with it. But all of these things kind of like a lot of talking, and that make is carry out. But just think about it, level of significance. If you have 95%, that'll be 5, and that's what you need to remember. I will be talking about this idea concepts after that, okay? Because it's a bit too early right now. So here, so you say that since the level of significance, the probability of making an error, it should be small. So you want that error to be as small as possible. Again, 95% confident about something, that means 5% for all error. Okay, so that's been most typically by default. This is the most reasonable one. Okay, this is the most typical one. People are always gonna say I'm 95% confident about something. Confident about something. Okay. Etc. Okay. So we use also 1%. We're making this error very for bad repercussion. Okay. You're gonna get examples for that. We also use 0.10%. Okay. So that's also some idea that we can use. But the most idea, if I don't give you anything, if I give you, we're making a study and I don't specify anything, by default, you have to use 0.05 for alpha. This is by default. If I don't give you anything, this one I have to set it to you. I have to say to you. Even you can have alpha is equal to 0.20 as well. Okay. So, etc. Any question about that? And it might be a little bit confusing. Okay, before I keep going, we're gonna come back to the alpha again. We need to talk about something called a test statistic. That's a very important aspect. If you're doing for p hat, this is the formula for the test statistics. It's gonna be p hat minus p o, and then the over square of p o 1 minus p over n. This is a formula that you need to write down. Okay, there's no real explanation for now for that one because you already saw that formula before. Let me just see where's that. I'm going to show where you found it before. I probably don't remember it. So this is a formula we saw before. It's just like we will write them down. Whenever we're doing the p hat plus or minus e, we did say the e. We got e was something like that, like the z-score time the standard error. Okay, and the formula for the standard error was something like this: the square root of p hat 1 minus p hat over n. See, this is the same formula right here that you put over there again. So this is nothing new. The only difference, I will try to make it into a z value, okay, which is the observed value, which is p hat, take away p naught, okay, p naught over, and then square root of p naught minus 1 p naught, and then over n. Okay, the reason I say p naught is we talked about earlier here. Let me just show it to you again. Whenever it's added, it's a p naught. Let me just show it to you again here. What was that thing again? Right here. See, no. Where's the name? Why did I give you the name again? Oh, the very first slide. Okay, let's so right here. See, so whatever that letter is, it say H naught or null hypothesis. And this one say alternative hypothesis or HA. Some books also write it as H1 as well. But whatever is the letter, so it's H naught. That's mean if I put P and this letter Y, that's mean P naught. Okay? That's what I wanted to point out to you. And then let's go back to our note. That will be the formula for the test statistics. Okay? So in the future, if they ask you to find the test statistics, this is how you're gonna find it. Okay? These are formula that just have to write it down in your notes. Write down notes so you can remember it. Okay? Make sure you add that formula in your notes. Okay, now. So I do not have to explain to you the test statistics. Okay, but you just have to read this one here. But let's read it anyway. So it said the test statistics are unlikely the sample portion could have happened by random chance had the null hypothesis been true. If the null hypothesis is true, then the test statistic should be close to 0. Therefore, the farther the test statistic is from 0, the more the null hypothesis is discredited. Okay? So the closer, okay, so that's why they wanted you to, that this is for reading, but I can explain it a little bit to you. So we have two things. You can have a claim. See what's that? This is my claim. My claim is P is greater than 0.25. Okay? So I'm gonna have my H naught and my H1 or HA. Here it is HA. For H naught, I'm going to say P is equal to 2.25 or less than, doesn't matter. And then if I say, and the next one be P is greater than 0.25. This is what happened. If HO is true, let me use a different color. If HO is true, is this one is true, then that means you must reject the claim. If HO is true, then reject. No. I don't want to say that way. Let me just say the way the book said it for now, so you guys don't get confused. Okay, this is what happened. So I'm going to stick with the book for the way the book does it for now. This one say, if the hypothesis is true, then the test statistic should be close to 0. Okay, so okay, just say that if HO is true, and then okay, I don't want to say that way now, but I also have to say right now. If HO is true, let me get my pen. Okay, then you say the test statistic is close to 0. That means that I'm going to use the T for test statistic. Let's call Z naught. The Z naught is close to 0. Okay, so that's mean close to 0, something like that. Okay. Therefore, the farther the test statistic from 0, the more the hypothesis is discredited. That means it's gonna be false if the other side happen. That means if Z naught is far away from 0. I mean far away from 0. Let's put goes to infinity, something like that. Far away from 0, then the HR will be false. Okay, that's the idea behind that. So this is just reading, kind of hard to understand sometimes if you kind of but if you pay attention, it kind of makes sense. But this is what I mean, I don't want to say too much right now because I don't want you to get confused about it. The reading is gonna be hard as well, but you're gonna understand it better whenever you do some problems. Okay. Any question about that so far? Okay, one last thing I want to point out to you. So before I keep going to the next section, whenever you used to have that bar here, remember this, the bar right here, the bell curve. You see, this is what happens. Suppose I say I'm 95% confident about something. Okay, it means the following thing. It means this whole thing here. Let's see, where's my pen? From here to there, this whole thing here means 95%. This is what we want to have. I'm 95% confident. This is what I want to have. The middle part here, the middle part is always 0. Okay, and that will be Z naught. Some easy value. Not Z naught, some Z value, not Z naught. So my mistake says Z naught. So this is some Z value. Okay. This is some Z value. Let's put Z alpha instead. This is what happened now. The 5%, that'll be this guy. That'll be alpha, which is equal to 5%. Okay. So here I'm gonna call it Z alpha. Z for now, I'm gonna call it Z alpha for now. This is what happened. Based on the little part right here that you see over there, if your Z naught is close to 0, the HR, this is right here, is closer to 0, then you're gonna have to say the hypothesis is true. If the hypothesis is true, then the result should be close to 0. And the on the other side, this is what you don't want to have. If it's away from 0, then you're gonna have to go to the rejection side. Okay, this can happen. Okay, if you go to the rejection side, that means the H0 is not true. Okay, that's the idea behind that. Anyway, we're gonna come back again to that the picture. Now, this is what I was talking about, something called the p-value. Okay, so it has to be extreme. Okay, so based on what we have, based on the Z0, you can deduct something called a p-value without a p-value. So for now, we can either use the TID3 or the what do you call it again? The TID3 or the StatDisk. Well, not StatDisk. You can use the other program that we use to calculate it as well. But this is the idea beyond that. If you have something like this, okay, let me just give you a definition so that'll be easier. So I'm not talking too much. Give me one moment. Let me get my eraser. This is what you need to understand about the p-value. All of this ain't gonna be without is fine as well, but this is the basic thing for p-value. Okay? We're gonna do something like that. If your p-value is greater than alpha, you're gonna say do not reject HO. That's the wording for that. If your p-value is less than or equal than alpha, you're gonna say reject HO. In fact, the p-value is some value dictated. P-value usually something like this. Some value. Let's see, where's that? Dependent of, you can say P of Z, okay, less than Z0, okay? You're gonna have to use the something like that, okay? So whatever is used for Z0, you're gonna put it there. So you're gonna say less for Z0, or it can also be p-value can also be something like this. Is equal to 1 minus P of Z less than Z0. Okay. And then use that symbol with you before. So let me just we check that one. This one is the same thing as saying p-value. P of Z greater than Z0. So if you're dealing with something that's more than, use this one. If you have something that's less than, you're gonna use this one. Okay. And then if it's then I will talk about the other one soon. We're gonna see two examples. Okay. So we can try to do a small example for p-value example. Let's see. Let's try to do this one. Does anybody have any questions so far? This little thing I have to put over there, make sure you write down when you know. If your p-value is greater than alpha, do not reject HO. If your p-value is less than or equal than alpha, reject HO. Okay? And I'm going to do the same thing over there as well. let me see, right here. So we also do the same thing right here. If your Z naught is greater than the Z sub alpha, you're gonna say reject HO. If it is Z naught, what do you call them, is less than Z sub alpha, you're gonna say do not reject HO. That's very important. HO. I mean, what that means that the note I'm having here, they're not complete because they are from Pearson. But we can do something like that. This is called the traditional way. Traditional. Okay, I know it's much terms. The only thing you have to do right now, just write the formula I just wrote right here, and then the other formula. The other one is called the p-value method. Okay, so just write them down. These two expressions are very important to write them down. Okay, make sure you write them down. So let's draw the big picture here. This one say, did I see an example? Okay, say an hypothesis test was concluded to see if 10% of the time that the weather report states a 10% chance of rain, that there is rain. Of 300 randomly selected days with a 10% chance of rain, 6% of them has rain. The p-value was found to be 0.02. So we need to interpret the p-value. Okay. So the p-value is going to be 0.02. So let's quickly do whatever they say here. All right. So your chance of rain is to be p equal to 10%, right? Okay. And then so your p-value is on that side. Would be like the 2% will be either right here or right there. Okay. But you can also calculate something here. Okay, so say if another 200 people 8 days was that's only 2% of change, that the number of day of one will be less than 18 or more than 42%. Okay, this is all of this will be Chinese. Okay, what you can do if you look at the p-value as 0.02, all right? And then notice that 0.02, you can say that. What can you say about this one? So that's something kind of crazy here. So it's a 300 one time select pay for 10% short of rain, 6% of other rain. The p-value was found to be 0.02. Interpret this value, the p-value, okay? So the 2% will be either here or there, okay? So they give you p hat at 6%. This is p hat. It be 0.06. Okay, that's your p hat. And then the p naught, this is the one that you find. It's equal to 0.10. Okay, that means if I have to do the unknown hypothesis, I'm going to do something like this. I have H naught and H1. I will say P is equal to 0.10. And then now P naught. Okay, is less than 0.10. Okay, because the p hat is 0.06. Okay, that's when this is going to happen. Now, to find out the p-value is 0.02. We need to interpret that. So if your p hat is 0.02, okay, I know what we're talking earlier about about the alpha. That's why I was wondering about, because they put up alpha. Suppose alpha here is 0.05, just like we were talking earlier before. Notice that we have here your p-value is like less than alpha. Okay. So let me just show the picture earlier we have earlier today. See, I say that if you p-value here, p-value was an example, the p-value was 0.02. Okay, and the alpha was 0.05 by default. If it's not given, it's going to be 0.05. That means you need to reject HO. That's the idea behind that. Okay, so let's see. So this is what happened. Because this is 0.05, this is 0.02, and then 0.05. That means reject HO. If you reject HO, we have no evidence for that. This is correct. That's what I'm trying to tell you. That means we have evidence that it's going to be less than 0.10. Okay, that's the idea behind that. So that's why they say here. They say if another 200 days while 50% suffering was going to be selected, then there's only 2% chance that the number of days suffering will be less than 18, or 6%, or more than 42% or 14%. Okay, so these are a lot of writing if you want to try to understand it, but the example we're going to be doing will be mainly based on the p-value and the alpha as well. But this is just try to understand the idea. So for the 6% here is going to give you 18 for the 200 days, okay, etc. Right? Then less than 18 or 6%, or more than 42 or 14%. Okay, so the 6% is given to you by something like this, which is x over n. It means that 18 out of 300 days, we give you 6%. Okay, and I don't want to be like 42%, something like that. Okay. Any question about that part? Any questions? Am I mute? Any questions? Hello? Okay, no questions. So, two things we need to understand whenever you do the hypothesis testing, we need to know this one say come up with an idea or hypothesis. Rather HO and HA. Earlier in the example, the first thing I did, the thing I did also is to write down HA and H1. HO and H1. Okay. First of all, you need to know, I don't say the idea or hypothesis. First of all, you need to know the claim. First, know the claim, what you want to say, what the person is saying about. The reason I say claim instead of idea is that a claim is something that can either be true or false. Okay, it's a statement that can be true or false. Once you know your claim, you can, second thing is to build up your hypothesis as HA, HO, H0, or HA. Okay, we can build up like this. Suppose my claim was P is greater than 0.30. Okay, that's my claim. That statement can either be true or false. Okay, so therefore I'm gonna either say, because HA only accept inequalities, I'm gonna put my claim right here. P is greater than 0.30. And then the other one be P is equal to 0.30. Some people also can put less than or equal than 0.30, the same thing. Okay, so at the same thing, the second thing you need to do, this is 1 and 2. The second thing you need to know what's the significance level. If it's not given by default, This is gonna be 0.05. Okay, by default. That's the thing you need to understand. Then also consider that the test statistic. The test statistic will be Z sub 0 or Z naught is equal to, if you're doing for proportion, so assuming we're doing for proportion. Let's see, proportion. Proportion, okay? The formula will be P hat minus P naught, I can just say P, doesn't matter, over the square root of P 1 minus P over N. That's the formula I would know before, okay? After that, the same consensus is just check to be distribution and condition. We're gonna always assume this is normal. We talked about it before, the conditions, whenever NP greater than 10, something like that, but don't about that part. But we're gonna be talking about what I want to tell you is like how to find the p-value and then compare the p-value. This is a thing that you're gonna need to know. Okay, so let's keep going. That's the next thing. Next time we're gonna be like compute the test statistic, which we're gonna be doing. They're gonna say compute the p-value. P-value you can find in many ways, and then you're gonna say if the p-value is less than alpha, you're gonna say reject HO. If it's greater than alpha, you're gonna say fail to reject HO, or you're gonna say do not reject. With the same thing, you can say do not reject. Do not reject. That's the same thing as that, all right? Then you're gonna do a conclusion. The conclusion is for everybody to understand. Okay. So now, to find the p-value, you have many ways of finding it. Okay. Let me see. That's one of the reasons I really like all the notes from Pearson here. So it's depending on how to get the p-value. Just like we say, for the p-value, again, you're gonna compute the test statistic Z naught, Z sub 0. Let me just erase that. Let's put it again. You're gonna find Z sub 0 right here. Okay, but this is what happened. You're gonna have a few cases. Okay, so I think I should wait for the next chapter to do that, for the next section. Yeah, I'm gonna explain it for the p-value. I'm gonna explain it to you on the next section. Okay, so bear with me. I think it's better that way because you're gonna have 3 cases. You're gonna have 3 cases. When each time you're gonna have 3 cases. You're gonna have a case something like this. You're gonna have HO. So when I say P, I give you something like P. I can say HO and H1. I mean H1 right here. I can say P is equal to some P not value, something like that, some value, and this one will be P less than P not. Okay. Or you can have something like this. It's depending on your claim, depending on the claim. Or you can have something like this, HO, H1, or HA if you want to. P is equal to some value P naught. And then P not equal to P naught. Okay. And then or you can have HO, H1, P equal to P naught, and then P is greater than P naught. So based on your claim, you can have 3 cases, either or. You have to be one of them. Based on that, you're gonna have some Z sub 0. Okay. So the next section I'm gonna be showing, you're gonna show I'm gonna find Z sub 0 for each one of them. Okay. It's not explained in the book clearly, but but I'm gonna have to explain it to you. So let's go that way here. This is what happened. You're gonna have 3 cases. One is called the left tail. We say left tail, because in the HA you have less than. This one is called a right tail because in the HA you have a greater than. That's why I say right. This one is called a two tail because on the HA you have not equal to, because it's gonna be at two sides. Okay. In this case, this is how you get in this case, you're gonna deduct something called Z naught anyway, right? You're gonna have a Z naught. This the test statistic Z naught. Okay. So why do we find the p-value here? Here, the p-value is equal to P of Z less than Z naught. Okay. And the next one, you're gonna find the test statistic Z sub 0, the p-value is equal to P of Z greater than Z sub 0. And the last one, because it is a two tail, okay, so two things can happen. It can either be p-value is equal to 2 times of P or Z less than Z sub 0, or you can say p-value is equal to 2 times P of Z greater than Z sub 0. This is how you find them. Okay. So the last one will be dependent on the sign of Z, the sign of Z sub 0. Okay. So you have more things. So the things that with StatCrunch, we can easily do it. Right. So this I find if you I'm saying that if you have to find them by hands, I already teach you how to find them using StatCrunch, or you can also use the TI-84 to find the area or the probability of a value. Okay. In this case, whenever you have to do this one, in this case, the normal distribution will be as follow. The mean will be assumed to be 0. No, I don't want to say that right now. To have a confusion. So let's leave it like that for now. Okay. For now. This is if you have to do everything by hand. Any questions so far? Okay. So this is what we have here. This is a picture of a left tail. I look like, so the p-value based on the probability that the p is, if p is equal to p sub 0, another random sample taken in the area is in the same sample size, then the new sample proportion will be less than observed value proportion. So what that is like, this is again Chinese. So what you're gonna be doing, your p-value is supposed to be as extreme as possible. Okay, p-value is supposed to be as extreme as possible. That's why if your p-value is bigger than alpha, in that case would be because a left tail. In that case, this one be the alpha. Okay, the p-value can be bigger than that one, but that's just definitions. Okay, that's how to show you how it look like. Okay, for left tail means that the area is shaded on the left side. A right tail means that it's shaded on the right side. That's what you have to remember here. Okay. So let me just erase that part from the notes so I don't get confused right here. Just remove that. It's better the way it is. Let's keep it simple. So the only thing we have to remember, left tail, it means less than or equal to, you shade on the left side. Okay. Right tail, shape on the right side. Okay. And then two tail, shade on both sides. That's all you have to remember here. Okay, all of these things are just wording for you to understand, for you to read. But you remember that two tails look like this, or one tail look like the other one. It's a one tail, white tail, and this is a left tail. Just remember that. That's all you have to remember for the shape. Okay. Any questions so far? Okay. This one say 45% of American have type O blood. A study was done to see if the percentage is the percent differ for college students. 40% of the 1,000 randomly selected students have type O blood. The p-value was found to be 0.2. Okay. So we want to know whether the p-value was found to be 0.2. So by default, they say that a study was done to see if the person differ for college students. Okay, so for this person of them, okay, they say the p-value is okay, something like that. Okay, so we're going to say something like this. You say two-tailed test. Okay, the test will be the differs. That'll be, they want to know if they differ. That'll be a two-tailed test. Okay, so if I do something like this, and I have HO and H1. Okay, I put this thing like that. I put P right here and P over there. So you're gonna see not equal to 0.45. Okay, this one will be equal to 0.45. So I want to know. So for the students, we found out 40% of them, they do not have that, right? Okay, so this is what they say. So this one say if 45% of the collection do have type O blood, and if another 1,000 selected students are tested, then there's 20% of chance that either fewer than 43% or greater than 47% of them, or a group of students will have type O blood. So that will be that is like the conclusion that is trying to do here. Okay. Again, the notes we don't want to use here, like Pearson is not using the alpha here, which I want to use, but we're gonna go with that for now. Okay, it's if 45% of the college students do have a type O blood, okay, and if another group of students, if another 1,000 random selection are tested, then there is 20% of chance that either fewer than 42% or greater than 47% of this new group of them will have type O blood. This is the conclusion they do. Okay. And they find the p-value to be at 0.2. All right. So so this is what happened. If you are supposed to use the p-value, the what do you call it again, the alpha, if you compare with the p-value, as you can see, the p-value is greater than alpha. If the p-value is greater than alpha, it means that do not reject HO. Okay, that's one thing also. But this is the conclusion they have, and this is right here. Okay, so let's hope that we have more examples that be backing up what I want to say. Okay, or probably I'm giving you too much notes. So again, we're talking about earlier for the random sample. Okay, we have to have a p-value. You need to be random sample. Okay, it should be randomly selected, and we also talk about this one. It has to be large enough. We talked about this before. Okay, there's a new thing that I say here. These are new. It say without the placement. This is not new. If the sample is collected for replacement, then the population size is at least 10 times bigger than the sample size. So here, you have to keep this little note on your note just in case it asks a question about it, okay? You have to be for replacement and also have a idea of independence, just in case I have a question about on the exam, okay? But the first one, we have to have these two, okay? You must have the first two all the time. Any questions so far? And the last one here, the hypothesis is true. Okay, so I'm gonna assume that for now. So the next one, and the person now is to do some example on StatCrunch, so you can see what we need to do. I do not have the let's do some by hand. So this one say I have more than 70% of all dogs at their babies shots. 590 of the if 800 dogs examined at their baby, I'm sorry, rabbis shots. Okay, so this is how we do it. So you're gonna say you want to know whether more than the rabbi shot. So as HO is going to be P is equal to 2.7. This is your null hypothesis statement. This is that the general statement right here. Okay. And then we're gonna try to find the first thing that you're gonna be doing, try to get the P hat. Okay, and then find the test statistics. Okay, the test statistic will be Z sub 0 is equal to P hat, whatever you got over here, minus 0.7 divided by the square root of P hat will be equal to 592 divided by 800. Okay, the time is kicking, so I'm gonna have to do this one a bit quick. So, so whatever I got that here, I'm gonna put it there, and I'm gonna do 0.7, 1 minus 0.7, and then divided by the square root, divided by 800. Whatever I got for Z sub 0, I'm gonna get the p-value. The p-value, because it's greater, is on the greater side, I'm going to p-value is equal to P of Z greater than whatever I find for p-value. Once I do that, I'm going to compare with alpha. Alpha is assumed to be 0.05. And I'm going to do my conclusion. Okay? So we're going to try to do that and StatCrunch. We don't have time. We have only 2 minutes. So I'm going to have to show how to do it. So you guys are going to have to practice that. So we're going to go to Stat. We're going to go to whatever, go to StatCrunch. Okay, I'm going to access that for unfortunately, so you can see. You're going to go to Stat, proportions, one sample, and then with summary. You're going to insert the values. Okay, so number of successes is going to be 592, number of observations 800. You're going to say next, calculate. Okay. Once you do that, you're going to need to put the null hypothesis, okay, which is 0.7. For the null, you're going to put greater than. Okay. So you're going to say calculate. When you click calculate, you give it the extent that you're looking for. And something by hand, I'm able to find this one here. It is simple proportion, which is 0.74. And then the test statistic Z sub 0 is going to be 2.47. Okay. Then your p-value will be 0.08. So this one be 2.47 right here. You don't have to put all of these things, and then that'll be 0.0068. That number is less than alpha. is less than alpha, that means reject HO. Whenever you say reject HO, that means we have no evidence that it is equal to 0.7. That means that means we have evidence that is greater than 0.7. Okay, that's what it means. So let me just give you the definition quickly. You have a few minutes left. Just quickly go over it. Oops, sorry. Right here. No. Give me 1 second, guys. 1 second. That's just my page. 1 second is right here. So here. So you're gonna say you have no evidence for this one because you say reject HO. That means you have evidence for that. This is the right thing. It means that if 70% of all dogs have their rabbi shot taken, if another select there's a 0.68% chance that there are more than 592 of them will have their rabbi shots. This is the way they did I'm sorry, I'm trying to go fast, but the idea is that you have evidence that this is more than 0.7. Okay, that's all. Okay, guys. So enjoy the rest of the evening. If you have any question, please stay. I was trying to watch on the last one. And I'll see you guys on Thursday.